Japan did not find land for this airport by alone. It built a long island in the sea.
Beneath the runway was not natural land, but soft seabed forced to carry an airport.
The airport was finished, but the sea never stopped testing it.
Before the runway, Japan had to draw an island across the...
The outline was drawn in stone, but the ground below was still soft. Before Japan could build upward, the seabed had to release the water trapped inside it.
Airport Island began as mud, water, and a straight line across the bay.
Japan was no longer building near the sea. It was building land on top of it.
The island had appeared, but it still had to become strong enough to carry an airport.
Every time the seabed settled, engineers raised the island again. The runway could only be straight if the island beneath it stayed controlled.
At last, the island was no longer just reclaimed land. It was ready to become an airport.
The island was stable enough to us failure. Now Japan had to turn it into a runway.
Even the runway was built as part of the island's balance.
The island needed one more lifeline: a bridge back to Japan.
The island now had a runway, a road to shore, and the shape of an airport. The island had become land. The runway had taken shape Turp's End. Now, it needed a terminal.
Unlike a monument, this terminal was built long and low curve, shaped by the island itself.
Every building on the island still depended on the seabed beneath it.
The island had become an airport, but it still had to prove it could operate in the sea. Japan had built the island, now the airport had to prove it could work.
Even after construction, the island still had to be measured, watched, and adjusted.
For the first time, aircraft would test the island Japan built from the sea.
Japan did not defeat the sea until
The Netherlands did not build higher land, but it built gates against the sea.
Behind these gates, much of the country lies low and flat.
When the North Sea rises, Dutch engineering has only one job: hold the line.
The first battle was not above the water chamber, it was on the seabed. Before the gates could close the sea, the Dutch had to build a foundation inside the tide. The Dutch could not build the gates first, Tan Kutru, they had to tame the seabed.
Every pier would stand against tide, storm, and time.
Piece by piece, the barrier moved from land into the tide.
Now the sea had a line of foundations. Soon, concrete would rise from it.
The foundations were ready, Sia. Now the barrier had to rise from the tide. The doors arrived by water because the barrier belonged to the tide.
The barrier finally had its shape. Concrete bones, steel doors, and the sea still moving through it.
The barrier had steel doors stowed. Now they had to learn how to move. Each gate had to drop with precision, then hold against the North Sea.
Each gate had to drop with precision, then hold against the North Sea.
The Dutch did not only build gates, Kran. They built a system to read the water.
Now the barrier could move Katohdins. The next test would come from the sea. The barrier was built for this moment, the Kokhod, when the North Sea begins to rise. The gate moved slowly, but the entire delta waited behind it. Outside, the sea kept pushing. Inside, the lowland stayed protected. The North Sea reached the gates Kantalas, and the water stopped moving inland. Morning came, and the low land behind the barrier was still safe. When the storm passed, the gates returned the tide to the delta. A country below the sea survives by checking every detail.
The Netherlands did not defeat the sea.
They did not go around the Alps. They drilled straight through them.
Above, the mountains stood in silence. Below, the railway crossed beneath them.
To connect Europe faster, engineers had to bore through one of the hardest mountain ranges on Earth.
Before the tunnel could cross the Alps, the mountains had to be opened one face at a time.
The Alps were now open at both ends, but the real work was just beginning.
To break through the Alps, engineers first had to read the rock like a map.
The mountain did not move twain for kind, so the machine would have to go inside it.
From both ends of the Alps, the tunnel was slowly eating the mountain from within.
The Alps were no longer just mountains, Kachik. They were becoming a long, engineered corridor for trains.
From both ends of the Alps, the mountain was being hollowed out one ring at a time. Inside the mountain, the tunnel was built as a precise ring of concrete after every cut.
Day after day, the machine pushed a railway tube deeper under the Alps. Deep under the Alps, the railway was becoming a hidden line of concrete and steel. The mountain was no longer the obstacle to Vierd. Now the tunnel had to become a railway. Inside the rock, every meter had to be reinforced for the trains to come. The tunnel was no longer just a hole in the mountain. Note, it was becoming a complete railway system. At last, the mountains no longer blocked the railway crest. The train could go straight through them. They drilled through the Alps tracile and built one of the longest hidden railway routes on Earth.
After years of drilling, the two ends of the tunnel were finally close enough to meet.
At last, the mountain opened into one continuous railway line.
The tunnel was built for trains like this, PED, fast, quiet, and deep under the mountains.
They built a machine deep under the ground to study the first moments of the universe.
Above, the city stayed quiet. Below, a ring of steel and concrete waited for particles moving near the speed of light.
The world above looked ordinary. The world below would become one of the largest scientific machines ever built.
To build the collider, engineers first had to open a way down into the planet. Before the machine could probe the universe, engineers had to carve a hidden world beneath the ground.
To build the collider, engineers had to open a path from the surface to the underground ring.
What looked like a simple hole in the ground was actually the doorway to a machine dozens of kilometers across.
On the surface, life looked normal. Below it, the machine was slowly taking shape.
The tunnel was no longer empty. It was becoming a precise circle of science under Switzerland.
The machine was still hidden, but the underground ring was now real. The tunnel was ready. Now the machine itself had to be lowered into it, piece by piece.
Every magnet had to sit in the ring with extraordinary precision. It counts, or the particles would never stay on course. Inside the ring, everything had to be almost perfectly empty,
so particles could race without being disturbed.
A time-lapse view reveals the accelerator ring. Superconducting magnets and cryogenic lines snake through the tunnel, maintaining the extreme cold required for operation.
Deep under Switzerland, the ring was becoming a machine that could hold particles on a path around the world's most exact circle of science.
The ring was built, aiming. Now the real science hardware had to wake up inside it.
To bend a particle beam, the magnets had to become colder than deep space.
The collider needed eyes as big as buildings, hidden deep underground. The machine was no longer just a tunnel, a hals. It was a complete instrument, from beam pipe to detector. The machine was complete in cons. Now it had to be cooled, calibrated, and brought to life. The machine was built, cooled, and connected, and now it was time to see if particles could survive the ring.
Inside the ring, everything was ready except the beam itself.